In lesson 10.4, we're just going to do some general volume problems. So this is just some miscellaneous stuff from the previous 3 lessons that we've already talked about. Down below here we see a prism, and they're going to give us that the volume is 1,440 centimeters cubed. And we want to find the height. And so we know from previous experience that whenever we're talking about volumes of prism, that it is the area of the base times the height of the prism. Now, we can simplify this a little bit more, or maybe actually we could say complicate it more, I guess, because we know that the area of the base highlighted in yellow for a triangle is the same thing as saying 1/2 the base times the height of the triangle. So the b that we see in the volume formula for a prism in this particular example is 1/2 base height, because that's what the triangle is. Now, knowing what we have already, and from the diagram down below, I'm going to plug in some numbers. So I know they gave me what my volume is. I know that my volume was 1,440. That's the same as this V and this V on the left-hand side. They also tell me in my diagram that the base and the height of the right triangle are 15 and 8. So if I want to find the area of that triangular base, I know that that is 1/2 times 15 times 8. And so that is my base that I can plug in. And so I now have 1440 equals the area of the base, which is 1/2 15 times 8, or 15 times 8, excuse me. And the only thing I'm left with is this h thing that I'm trying to solve for. So really what I have is I have 1440 is equal to 60, when I multiply out all those numbers, times the h. And if I divide both sides by 60, I find out that the height of my prism will be that 1440 divided by 60, or in other words, 24 centimeters. Notice how this label is not cubed. That's because we are not looking for a volume. We're looking for the height of the prism. In our second example, another similar style problem, we are given the volume of the 40 degrees of this right cylinder, and so we want to find the radius. Now, part of the problem is they only give us the volume of the 40 degree sector. So what they're talking about, if you look at it, is this volume of the 40 degree sector is this volume right here that I'm going to be outlining in red. And so it's like a chunk out of the cylinder. Now the problem is we know that that's 40 degrees out of the 360. So if we think about that, 40 divided by 360 is the same thing as 1/9 of the volume of the total cylinder. So really what I would need to do in order to figure out the volume of the complete cylinder is, since I only have 1/9 of the volume present, I need to take the volume that they gave me. I need to take that volume of 2,814 meters cubed and multiply that by 9 to get the total volume of my cylinder, which in this case means that I would have 25,326 meters cubed when I multiply 2814 by 9. So now if I want to find my volume of the complete cylinder, that's why I'm multiplying by the 9. And this time what I want to do is I want to find out the radius then of this thing. And so to find the radius, what I know is that if I have the volume, in my volume we have the formula down below here that volume equals the area of the base, which is the circle of course, times the height of that cylinder. But I can rewrite this for the area of the base as pi times my radius squared then, and then times the height of the cylinder. So keep in mind when you're looking at this that the b that's capitalized is the same thing as pi r squared. And if I fill out the information that I see now, I know that when I fill this out, I actually have that my total volume of my cylinder, 25,326, is going to be equal to pi times my radius squared times my height, or in other words, that I have 25,326 equals pi times, I'm looking for my radius, so I can't do anything with that yet, times the height of this cylinder, which is 14. Now, in order to solve this problem, I'm going to divide both sides by whatever's with the r stuff. So I divide the left-hand side and the right-hand side by the 14 and the pi. Don't forget to put around parentheses so you don't make a mistake when you're typing this into your calculator. And what that means, after I get done with that, is that I'm going to have r squared equal to whatever 25,326 divided by 14 pi is. And then after I get done with that, I'm going to square root it. So as I take my 25,326 and I divide it by the 14 pi, I get 575.82. But that's what r squared is. I don't want r squared. So that's why I have to square root both sides in order to get my r. And when I square root both sides to get my r, I find out that my radius then is the square root of 575.82, which is somewhere right around 24. And since we're in meters, for a linear measurement, it would be meters. So this is not exactly 24. Let me just check, actually. I can take the square root of that just to make sure. Oh, it is pretty close. It's within 1,000ths of that. So we're going to go, it's pretty much 24 as the radius. So the big idea here is, in this particular example, we had a sector, which is only part of a circle. We had to multiply it by something to get the complete volume instead of just the partial volume of the cylinder that we had here. And then we use the formula and solve for the unknown.